Okay, good afternoon, everyone. And in this presentation, I will talk through my machine learning notebook and explain the complete modeling workflow from data preparation to model evaluation and final insights. And the goal of this project is to predict a continuous target variable using structured tabular data. This is a typical regression problem when accurate prediction can support better decision making. And rather than focusing only on model performance, this notebook emphasizes the full machine learning pipeline, including pre-processing, transformation, model selection, and validation. The main objective is to understand how each step influences model behavior. And the dataset contains multiple numerical and categorical features describing different attributes of the observations. These features are used to predict a target variable that shows strong skewness and variability. And this creates two main challenges. And the first, the data includes missing values and mixed feature tabs. Second, the target distribution is highly skewed, which can negatively affect regression performance. And therefore, the modeling strategy must carefully handle both pre-processing and statistic transformation. And the first major step in the notebook is pre-processing. Instead of manually cleaning data, I implemented a structured pre-processing pipeline using like the scikit-learn's calculum transformer and pipeline framework. And numerical variables are inputted using median values, while categorical variables are inputted with the most frequent category and then one hard encoded. And this approach ensures that the consistency across training and validation sets and prevents data leakage during cross validation. And one important lesson here is that pre processing is not just preparation, it directly affects model reliability. And the key decision in the notebook is applying a logarithmic transformation to the target variable because the target distribution is right skewed. Large values dominate the error function. This makes regression unstable and sensitive to outliers. And by applying a log transformation, the distribution becomes more symmetric, variance becomes more stable, and the model can focus on proportional difference rather than absolute number. And this significantly improves prediction stability. However, this introduces a practical consideration, like the predictions must be transformed back to the original scale before evaluation, and this dominates how statistical transformation improves model performance but require care for interpretation. And for modeling, I used the light GBM over right here. So, gradient boosting decision tree algorithm. Light GBM is widely used in structured data problems because it captures nonlinear relationships efficiently and handles large data sets with strong performance. Compared with linear regression, models complex interaction automatically. Compared with deep learning, it requires less feature scheduling and training time. And this makes it well suited for tabular regression tasks. And for model evaluation validation, To evaluate performance reliability, the notebook uses k-fold cross-validation. And instead of a single train test split, the data is divided into multiple folds and the model is trained repeatedly on different subsets. This produces a more stable estimate of generalization performance and reduce evaluation bias. And these steps reflects an important principle. Model performance should be validated statistically, not just observed once. And another important component is the hyperparameter tuning. Instead of using graph search, the notebook use randomized sampling of hyperparameters, and this allows efficient exploration of the parameter space while controlling computational cost. And the turning process improves the model performance by adjusting a complexity, learning rate, and tree structure. And this demonstrates how model configuration can significantly influence predictive accuracy. And look at the four modeling pipeline. Several important insights emerge. Like the first, the data transformation plays a critical role in regression performance. The log transformation allows significantly stabilization, like the predictions. Second, structure processing pipelines ensure the reproducibility and prevent leakage. Third, busting algorithms are highly effective for structured data but still depend heavily on proper input preparation. And fourth, evaluation methodology, especially cross-validation, is essential for trustworthy results. And finally, the model performance improvements come not from a single step, but from the combination of multi-careful decisions. And thank you.